Guys, welcome back to another video. I'm the Cubing Geek, and today we'll be doing our next biography series episode about Carl Friedrich Gauss. So without further ado, let's just get into it. Early life. Carl Gauss was born on April 30th, 1777 in Brunswick, Germany. His family was poor and his father wanted him to become a tradesman. But young Gauss showed an extraordinary gift for numbers. At the age of 7, Gauss astonished his teacher by quickly summing the numbers 1 through 10 in seconds, discovering the formula for the sum of an arithmetic series. This moment revealed the brilliance that would define his life. With support from patrons, Gauss studied at the University of Göttingen, where he began publishing results that would change mathematics forever. Major works: Disquisitiones Arithmeticae, 1801. Gauss's masterpiece in number theory, laying the foundation for modern mathematics. He introduced modular arithmetic, quadratic reciprocity, and methods still used in cryptography today. The fundamental theorem of algebra. Gauss proved that every polynomial equation has at least one complex root. His elegant proof reshaped algebra and analysis. Gaussian distribution, or the bell curve, the famous bell curve. In statistics, he developed the normal distribution, the bell curve, now essentially in probability, data science, and social sciences. Least squares method. Gauss invented this method to predict planetary orbits, minimizing errors in calculations. Today, it's used in machine learning, data fitting, and engineering. Non-Euclidean geometry. Gauss explored geometry beyond Euclid's rules, opening the door to new ideas of space that later influenced Einstein's theory of the relativity. Magnetism and geodesy. Gauss made major contributions to physics, mapping Earth's magnetic field and advancing precision in the measurement of land and space. Astronomy. At just 24, he correctly predicted the orbit of the dwarf planet Ceres, proving his genius to the scientific world. Later life and legacy. Gauss remained at Göttingen for most of his career, producing work that spanned mathematics, astronomy, and physics. Though often reserved and perfectionist, he shared ideas that continue to shape science centuries later. Carl Friedrich Gauss died on February 23, 1855, in Göttingen, Germany. His discoveries, from number theory to statistics, formed the backbone of modern mathematics and science. He is remembered not only as a prodigy, but as a universal genius whose influence reaches into nearly every field today. Now let's talk about his works. Before Gauss, number theory was a collection of problems and conjectures. In Disquisitiones Arithmeticae, 1801, Gauss built a complete framework introducing methods still used today. His work on modular arithmetic created the basis for coding theory and cryptography. The law of quadratic reciprocity, which he called the Golden Theorem, showed hidden symmetries in prime numbers. Modern encryption, including RSA, depends directly on Gauss's foundations. His mastery of integers earned him the title of Prince of Mathematicians. 2. Algebra. Mathematicians long suspected that polynomial equations must always have a root, but no one had fully proven it. Gauss published several different proofs over his lifetime, refining the argument each time. His first proof appeared in his doctoral thesis at age 22. This work gave complex numbers a firm place in mathematics. Today, the theorem guarantees that algebra and geometry are deeply connected. Since roots correspond to points on the complex plane, Gauss's clarity turned a conjecture into a cornerstone of mathematics. Statistics. While studying astronomy and errors in observation, Gauss discovered that measurement errors followed a predictable pattern. He modeled them with a bell-shaped curve, which became known as the Gaussian distribution. This idea explains phenomena from test scores to human height. The bell curve is central in social sciences, economics, and quality control. Its properties allow researchers to analyze uncertainty and variation with precision. Gauss's insight transformed statistics into a rigorous mathematical science. One example of the use of the Gaussian distribution can be IQ curves. When they measure IQ, they use Gaussian distribution to measure your levels of IQ. Least squares. In 1801, the dwarf planet Ceres disappeared from view after discovery. Using his new least squares method, Gauss accurately predicted its orbit, astonishing astronomers when Ceres was found exactly where he calculated. The method reduces random errors by squaring differences and minimizing the total. Today, least squares is the basis for regression analysis in statistics. It powers algorithms in AI, finance, and scientific research. Gauss turned data analysis into a mathematical discipline. Geometry. For centuries, Euclid's geometry was considered absolute. Gauss secretly investigated what would happen if parallel lines behaved differently. His calculations showed that consistent non-Euclidean geometries existed. Though cautious to publish his findings, anticipated later work by Loba, Lobachevsky and Bolyai. These ideas eventually shaped Einstein's theory of relativity, where curved space defines gravity. Gauss's quiet explorations hinted at a universe far beyond flat geometry. 6. Gauss collaborated with Wilhelm Weber to study magnetism, inventing sensitive instruments like the Gauss-Weber telegraph. He formulated Gauss's law in electromagnetism, describing how electric charges create fields. In geodesy, he applied advanced math to measure land and Earth's curvature with precision. His surveys improved maps and navigation. These contributions linked mathematics with the physical world in practical ways. Gauss's physics work was as influential as his pure math. And finally, astronomy. When Ceres was first observed in 1801, it soon disappeared behind the sun. Most thought it was lost forever. Gauss, using his new mathematical methods, calculated its orbit with extraordinary precision. Months later, astronomers looked where Gauss predicted, and there was Ceres. His success proved the power of mathematics in astronomy. It also connected his reputation as one of the greatest minds of his age. Thanks for watching. Hopefully you guys have enjoyed this video. Please help us get to 45,000 subscribers by the mid 2026. Please share it to every single family members you know. I just wanted to give a shout out to my friend Tucker. He just subscribed. Thanks. And the next episode will be coming soon. Can you guys guess by who is going to be next based on what the picture is currently showing right now? And follow for more of these videos.